This is line of balance. I have here in this axis, I have the floors from floor 1 to floor 10, for example. And on x-axis, I have time frame. Let's look at the block work. This is the productivity rates or the execution rate for block work. The slope of the line is in black color. This slope will determine the performance rate or the execution rate. So what does the slope mean here? It means I can achieve this amount of floors over this period of time. For the whole project, it means that I can finish the whole 10 floors during this duration. You can see, so this is my point of time here, completion of floor 10. If you go to the x-axis, so this is the duration of the block work. And I have achieved within this period, I have achieved all 10 floors. So the slope will determine your performance rate or how fast or how slow you are performing. Let's look at the plaster. And if you can realize the slope is different in this case. For plaster, the slope is more relaxed, is more stretched, right? It means that I can achieve the same 10 floors, but I take longer to complete compared to the block work. I can have here the duration for block work. You can see from the slope. So for plaster work, I have 10 floors, but the duration is really high. Okay. So if you take a slope, for example, you can say 1 floor per 5 days. But for plaster, I would assume here that you take maybe 8 days to complete the same floor, which you had 5 days for block work, because right now I need more time to complete the 10 floors. So this is the slope. I have here paint activities. It has also a specific slope. Let's also assume that it's 60 days per floor. Why am I explaining this right now? Because you have to really understand what's going on in our duration per floor. So it has to be really balanced. So if you want to take 15 days for block work, don't show 3 days for paint only. Okay, don't make a specific predecessor take a lot of time to complete while successful activities very quick to complete. So I have given two extremes right now. So let's assume that in paint activities, you have 10 days per floor. So this is a test loop based on your duration. What if you have tiles 3 days per floor? So the same floor will be completed in 3 days instead of 10 days compared to the paint. The slope is really steep right now. The rate is really steep. This is the orange bar here for tiles. And if you continue with this high performance, you're gonna at some point cause interruption. So by the time you reach floor 5, you have tiles clashing with you. Okay, and this is a problem. It is not effective method to plan projects. You wanna have everything at pace, right? So what will happen is the masons are really fast in execution. So why would you need 3 days at the first place? Maybe you have for paint, limited painters, for example. So you're gonna have only 3, but you have a bunch of masons. Maybe you have 10 masons availability. You have rich availability on site for masons. Because you have so many masons, so we're gonna finish the floor in 3 days. So at floor 5, approximately, you're gonna have interruption. A lot of masons are competing with the painters right now. So what will happen is you're gonna wait, right? How can you achieve tiles before the paint, for example? I'm only giving examples, by the way, but some people have different sequences. It's only an example. So you're gonna wait a little bit, okay? Have the 10 masons idle on site, then you allow for the paint to progress a little bit, then you continue working to complete with the 10 masons. So this is one scenario, which is not recommended. The second scenario, and as per the timeline here, I have my paint completed here. So it has to be completed after the paint, of course. So anywhere here, the paint has to be completed. Another scenario is the same finish date. I'm going to keep the same finish date, and I will draw a nice execution rate. Okay. So let's assume that I'm starting the tiles on the same date. So for example, in your project, as you bear your preference, you want to start the tiles 2 weeks after paint. For example, maybe you want that. So you want to minimize the risk of delay. So I'm going to keep 2 weeks here under the time axis here, 2 weeks. Then I'm going to start the tiles. But what is the execution rate right now? I want to look at the finish date of the paint activity, and maybe I want to finish maybe in 2 or 3 weeks after the paint is completed at the last floor. And with basic mathematics, if you have 2 points identified, you can draw a line between them. I know right now when I can start the activity and when I will be able to complete it. And it is not pure science, it's just something help you understand what's going on. So definitely don't complete the tiles within 2 days for each floor compared to 15 days of paint. You can understand the logic right now. Don't go too fast for successor, especially if the successor is really close to your activity. So you don't have to stick with a 2 weeks rule or 2 weeks rule here, but be reasonable. If your successors are somewhere within the range of 7 to 12 days, make something similar. So don't take 1 day, for example, for the direct successors. So be really reasonable. You don't have to keep everything at 7 days duration as well. It doesn't have to be the case because we are talking about the same amount of work. So one floor worth of work. Okay. So if you see here the productivity rate for the black line, it's different from the paint. I think it's steeper, but it's still reasonable. So if I'm gonna take 10 days for paint, I'm gonna take maybe 8 days for tiles, but not 3 days. So it will not clash with me. Another scenario, if you really have 10 masons on site and you wanna take full advantage of them, you don't want to sacrifice any masons, you wanna go full power. Okay, so first, you have to keep maybe 2 weeks after the completion of paint at the last floor. So this is my completion of all tiles in the project. And you have 10 masons. So 10 masons per floor. You have your productivity rates given to you right now. So 10 masons, you want to see how long 10 masons will take to complete the floor, right? So it is not something you want to determine now. It's a given. The 10 masons will take 3 days to complete the floor, right? Because you have 10 masons. So let's say that 10 masons will complete the floor in 3 days. So this is given as well, the execution rate based on the number of resources I have. So if you have this point known, if you have the productivity rates, then you can conclude the start date for the tiles in the project. And it makes sense because you want to really have some gap, some proper gap, adequate time frame lag. So if I'm going to start the paint here, I was referring here, but it's not wrong, but it's not right. I should refer here. So this is the start date of the paint. This is for the plaster. This is for the block work. You can see maybe there is a difference, like maybe, I don't know, like 1 week or 1 week to 2 weeks, okay, gap before I start any activity. But for the tiles, it's different. You have to wait maybe for 1.5 months. So long duration because you are going full power right now with 10 masons. So you want to wait for 1.5 months, then it's fine. If you want to go for 10 masons, go full power and complete on time. Something really you want to think about the line of balance. You want to avoid interruption here, the clash. You don't want to go too fast. If you want to go fast, wait for some time. Okay, don't go immediately after this activity. Maybe you want to wait some time so you can have the rate you want without interrupting line of balance. And we will look at it again from update perspective. We know the slope. That's my productivity rate for activity A. That's my plan for activity B. So red is the planned work. However, as per my update, I found myself starting activity B late. So if this is the timeline, this is my planned start for activity B. However, I started here and I have manpower on site, okay, to achieve activity B right now. And it is in delay. I have to do something about it. I have to recover the delay. You can see that the activity B planned slope is the same as activity B actual. They are the same slope. They are parallel. So it means that if I planned to have 10 labors, I already have 10 labors on site. So my slope is the same. So if I planned to complete one activity or one floor in 5 days, my actual is also 5 days. That's my performance rate right now. I'm gonna take 5 days. I'm not, but I started late. So I cannot take 5 days anymore because if I started 2 weeks late and if I am going with the same productivity rate, I'm gonna finish the activity 2 weeks late as well. So I have to do something about it. So the required is in yellow. I started late and I know my planned completion here. Basic mathematics. You have 2 points, you can draw a line. So I'm gonna draw a line between these known points. So this is my required productivity. You can find here that the slope is steeper than activity B actual, which makes sense because I am supposed to have more progress to recover the delay. Right now, I cannot finish the floor in 5 days. I have to finish it in 4 days. I have to recover the delay, the 2 weeks lost here delay. So that's my required productivity. This is what I want to call wrong productivity, the black dashed line here. A common mistake, and people don't understand the planning and how planning works. So maybe the client will see you starting 2 weeks in delay, and they're gonna tell you, you know what? I'm not satisfied with the 10 labors you have right now. You have to increase progress. Okay. Of course, we know that. He did not say anything wrong so far. He is right. But they will tell you something like, you have to recover all delays by the third floor. When we reach third floor, I expect all delays to be recovered. It's very common and we hear it all the time. But there is a problem with that. I started here. The client wanted me to recover delay at floor 3 here. So I have 2 points. I can draw a line. So this will be my required productivity as per client's requirements. Of course, it's steeper because he doesn't want to recover the delay here at floor 10. He want to recover the delay at floor 3. I have to do more work than I'm supposed to have right now. So I need to complete the floor in 2 days, not 4 days, based on the fact that I have to recover the delays and match the planned point here by floor 3. So the slope is really steep. He wants to recover all delays. So I need to bring maybe 20 masons instead of 10 to fulfill the requirement and recover the delay. But what happens is you have 20 masons on site right now. They are working really fast. They will recover the delay of activity B. They continue working and working until what? As we have seen before, this is not a good situation we want to be in, the clash point, because otherwise you cannot proceed further because activity B depends on activity A. So it will cause interruption. You're gonna have to wait a little bit, then continue again. So you wanna always avoid that. Who wants to hire 20 masons in a project to work for 2 or 3 weeks, then ask them to be idle doing nothing in the project? So next time the client wants you to recover by third floor, don't tell him it's not possible, but show him the chart, show him this is what's gonna happen. It might look evil from the client side that they are pushing everyone, but in my experience, surprisingly, they are willing to listen as well with good reasoning and proofs and some logic and common sense. They are willing to listen. So if you do something like that, you show them everything realistically, they're gonna listen and maybe do what you propose. But the problem is they do not just want you to rush, but they don't understand. The problem is they don't really pretend or something like that, but they do not understand what's going on. So they expect by floor 3 everything is gonna go well, but that's the rule of planning right now. Okay, we do things. Okay, anyone who is experienced can figure it out. By the way, it is not exclusive for planning. So they're gonna imagine that, okay, if we work too fast, we will make it to floor 3, but the paint is still in floor 7. Maybe it will clash. They can imagine it. Everyone can use their experience to forecast that. But our role as planning engineers is to quantify everything, to determine the exact point when we are going to recover the delay and how it will look like in future. Exactly. Not only you're doubting it or you are imagining it or there is a risk about. No, you are actually making a fact. You are reporting that with the same productivity rates we will have on site, we're gonna clash with the predecessor at maybe floor 6. So that's your rule. You want to quantify that. You want to propose something like that. Everyone knows how to recover delays. It's not exclusive. By experience, you're going to have a bunch of labors, but the only difference is many people or project managers make informed decisions based on experience only. So they're going to say, 10 are not enough. I want to recover the delay. Let's bring 14. Okay, just something by common sense. But what you can do when you have the facts in hand, you're gonna say something like, I'm gonna need exactly 12, okay, to take that long for any floor, like 3 days to be specific. Continue that with supervision, we're gonna complete on time. That's how you're gonna do it, because everyone knows the delay and everyone knows how to think about it. But the way you approach it mathematically and accurately, it's valuable. Okay, so that's the line of balance for schedule update.